Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good day to everyone. In this video, I would like to discuss the last subtopic in chapter 4, subtopic 4.3 about splines and piecewise interpolation. Here are the objectives of this subtopic. The first one, a student must be able to identify which one is a linear spline and also quadratic spline. And the second objective is everyone must know how to solve linear and also quadratic spline. These are the things that we will discuss in this video. So we will start with the introduction first, then we go to the linear or first order spline interpolation, the next one quadratic or second order spline interpolation, and last but not least we will do some exercises for more understanding. Before this, we already discussed about Newton polynomial interpolation and also Lagrange polynomial interpolation, where both of that method can solve for higher order polynomial interpolation. Actually, higher order polynomial interpolation is not the best choice to interpolate for large number of data. Why? Because it can cause runoff error and also overshoot. The graph tends to swing through while oscillation in the vicinity of abrupt change. You can see the example from the graph above. The first graph, we have third order polynomial and the graph is so nice. But when you go to the fifth order polynomial, seventh order polynomial and so on, the graphs start to oscillate. So how to avoid the problem? So we will use alternative approach called spline interpolation method, where this method will apply lower order polynomial to subset of data points. And this method also can cap the oscillation to a minimum by using small subset of points for each interval. So in this subtopic, we have two types of spline interpolation. The first one, linear or first order spline interpolation, and the second one, we call it as quadratic or second order spline interpolation. Now, let's see, what is a linear or first order spline interpolation about? The basic idea of first order spline is we are going to find the equation of straight line that connecting each pair of the interval. So for example, this graph, so we have 4 points here, point number 1, point number 2, number 3, and number 4. And all the points here connect by the straight line. So now we are going to find the equation of straight line for S1, S2, and also S3. Here is the formula for first order spline interpolation. So we start from S1 until Sn minus 1. Why until Sn minus 1? Okay, let's say we have 4 points. Point number 1, number 2, number 3, and point number 4. And each point were connected by straight line. So this is line number 1, line number 2, line number 3. So we will have S1, S2, S3. For better understanding, let's go to the example. Here I have a set of data and I need to derive a set of linear functions for the given data and I need to evaluate at x equal to 6.5. So how many data that I have? So I have 4 data. So from that I will have 3 straight lines. So this one equation S1, equation S2, and equation S3. And I need to evaluate at x equal to 6.5. So 6.5 is in between 5 and 8. Here are the solution for the example. Number 1, since we have 4 data, so we can determine 3 spline function. We need to use the formula for first order spline interpolation. So we will have S1, S2, and S3. Next, we need to estimate at x equal to 6.5. Since x equal to 6.5 lies between 5 and 8, so we choose S2 for our prediction. Just substitute all the value we have. So at x equal to 6.5, our estimation is 3.4. Now let's go to quadratic or second order spline interpolation. If for first order spline interpolation, we are going to find the equation of straight line. So for second order, we are going to find the quadratic equation that connecting each pair of the interval. in general, the quadratic spline function is this equation. Okay, if you see, we have si equal to ai plus bix minus xi plus cix minus ii square from xi until xi plus 1. Here we have a, b and c, where a, b, c is a constant. So how to calculate the value for a, b and c? So we will use this formula. Now let's go to the example. Here we have a set of data. So the first one, we need to fit the data with second order spline, and the second question, we need to evaluate at x equal to 2.2 and x equal to 3.3. So from here we have 4 data, and of course we will have S1, S2 and S3. The question asks you to evaluate x is equal to 2.2. 2.2 is in between 2 and 2.5. While for x is equal to 3.3, this one is in between 3 and 3.5. So let's go to the solution. Okay, for S1, S1 is equal to A1 plus B1 x minus x1 plus C1 x minus x1 square. So what is A1, B1 and C1? So by using the formula given, so A1 is equal to F1, so 0.125. For the first calculation, C1 always equal to 0. H1 is equal to x2 minus x1, so we will have 0.5. And how to calculate our B1? So by using this formula, substitute all the value and rearrange. So B1 is equal to minus 0.122. Then substitute back into our S1. So this is our equation S1 for from 2 until 2.5. Same goes to equation S2. So S2 is equal to A2 plus B2 x minus x2 plus C2 x minus x2 square. So now let's find the value for A2, B2 and C2 by using the same formula before. So this is the value for A2, this is value for H2, value for B2 and value for C2. Substitute all the value into our S2. So this is our equation from 2.5 until 3. Then continue for S3. Repeat the same procedure as before. Okay, we need to find the value for A3, H3, B3 and C3. Substitute into our formula. So this is equation for S3 from 3 until 3.5. Now let's start our calculation. First one, for x is equal to 2.2. This one is in between 2 and also 2.5, where this one is for S1. So you just substitute 2.2 in our equation. So S1 is equal to 0.1006. Next one, x is equal to 3.3. 3.3 is in between 3 and also 3.5. So we will choose as 3. Substitute 3.3 into our equation and we will have S3 is equal to 0.0337. I hope everybody can understand all the explanation before about first order spline and also second order spline. Here's some exercises for you to try for more understanding. Okay guys, thank you and good luck.